This is the largest single object ever discovered in the universe. It's called Ton 618, a black hole so enormous that light itself takes 2 weeks just to cross it. Drop our entire solar system inside, and it would vanish like a grain of sand in an ocean. But the size is only where the story begins, because almost everything about this monster shouldn't be possible. Ton 618 is a special kind of black hole, what astronomers call ultramassive. Most galaxies have a supermassive black hole at their core, millions or billions of times the sun's mass. This one is in a league of its own. It sits at the heart of a quasar, a black hole feeding so violently on gas and stars that the matter spiraling in superheats and blazes. And it's not just any quasar. It's one of the brightest objects in the entire universe. Here's the strange part. When we first found it, we had no idea what we were looking at. Back in 1957, at an observatory in Mexico, astronomers cataloging the sky noted a faint, pale blue dot. Nothing special, just another point of light. It sat in that catalog, ignored, for over a decade. Not until the 1970s did astronomers measure its light and realize the truth. That faint little dot wasn't a star at all. It was a black hole 66 billion times the mass of our sun, and its light had traveled more than 10 billion years to reach us. We'd been staring at the largest object in the universe and mistook it for a speck. Let's talk about that light. A quasar shines because of the chaos around it. Gas falling inward forms a swirling disk, heated by friction to millions of degrees. Ton 618 pours out more than 100 trillion times the energy of our sun. We can see it clearly from over 10 billion light-years away, almost all the way across the observable universe. If you placed it where our nearest neighbor star is, it would shine brighter than the noonday sun and cook the Earth in an instant. A single object, outshining a trillion stars. So what's actually producing all that light? Not the black hole. It gives off nothing. It's the disk. Gas, spiraling inward, piles up into a flattened whirlpool of plasma, vast beyond imagining, shredded and crushed and heated by friction until it screams across every wavelength of light. What we see when we look at Ton 618 isn't the monster itself. It's the death glow of everything falling in. Now, the number that defines it, 66 billion times the mass of our sun. For perspective, the black hole at the center of our own galaxy, Sagittarius A star, is 4 million solar masses, and that already sounds incomprehensible. Ton 618 is roughly 15,000 times heavier. Even M87, the first black hole ever photographed, is 10 times lighter than this thing. Ton 618 doesn't just break the scale, it redefines it. But wait, how do you weigh something 10 billion light-years away that gives off no light of its own? You watch the gas. Around the black hole, clouds of gas whip in orbit at staggering speeds, and the faster they move, the more mass must be holding them. By measuring how that gas smears and stretches its own light, astronomers can weigh the giant pulling on it. We calculated the mass of a monster we have never even seen, just by watching how fast it makes things spin. And let that number settle for a second. 66 billion suns isn't just heavy for a black hole. It rivals an entire galaxy. That single point outweighs all the stars in some small galaxies combined. And it's in the same league as every star in our own Milky Way, added together. A whole galaxy's worth of mass, collapsed into one dark point you could never even see. And all that mass creates a staggering size. The event horizon, the point of no return, stretches about 1,300 times the distance from the Earth to the Sun in every direction. Let me make that real. Our entire solar system, out to Neptune, would fit inside more than 40 times over. Light from one edge takes about 2 weeks to reach the other. If it replaced our sun, its event horizon wouldn't just swallow the planets. It would engulf the asteroid belt, the Kuiper belt, and reach toward the very edge of the solar system. Everything you've ever known, gone, inside a single shadow. So what would it be like to approach it? Strangely, peaceful at first. Remember, the bigger the black hole, the gentler the edge. A small one would tear you apart long before you arrived. But Ton 618 is so vast, you could cross the event horizon and feel absolutely nothing. No alarm, no pain. Just a quiet, invisible line you can never cross back over. And if you looked back over your shoulder as you fell, you'd see the entire universe speed up behind you, stars racing through their lifetimes, the cosmos fast-forwarding, as your own time slowed to a crawl. From the outside, anyone watching would see you slow, freeze, and fade away forever at the edge of the dark. But here's the part that haunts me. Because it's over 10 billion light-years away, we are not seeing it as it is now. We're seeing light that left it when the universe was young, billions of years before the Earth or the Sun existed. The TUN 618 in our telescopes is a ghost. The real one has had 10 billion more years to feed and grow. Which means right now, somewhere across the universe, it could be even bigger. And we have no way to know. So could we ever go there? No, not ever. TUN 618 is so far away that even traveling at the speed of light, you would never arrive. The universe is expanding so fast that the space between us is stretching quicker than light could ever close it. It is, and always will be, completely unreachable, a ghost of ancient light, forever beyond our grasp. All we can do is watch. So is TUN 618 still the biggest? Honestly, it's contested. There are challengers. A black hole called Phoenix A may be even larger, perhaps 100 billion suns, though that figure is shaky. Others, like Holmberg 15A, have been measured more carefully but come in smaller. TUN 618 remains one of the largest ever reliably weighed, the reigning champion of a very strange contest where the trophy is uncertainty itself. Which leads to the deepest question of all. How did it get so big? Black holes grow slowly, over billions of years, but this was already a giant when the universe was only a few billion years old. In fact, physicists calculate that a black hole feeding normally should top out around 50 billion suns. It should run out of food. TUN 618 blew past that limit. So how? Did countless black holes merge? Did it collapse straight out of an enormous gas cloud in the early universe? The honest answer is, we don't fully know. The biggest object we've ever found is also one of the biggest mysteries. And here's the final, staggering thought. Even monsters like this die. Black holes slowly leak their energy away, a whisper called Hawking radiation. But for one this size, the timescale is beyond comprehension. Something like a 1 followed by 100 zeros in years. Long after the last star has burned out, long after the universe has gone black and cold and empty, TUN 618 and its kind will still be there, the very last lights fading into eternity. They were here near the beginning, and they will be the last things standing at the end. TUN 618 is a reminder of how small we really are. A single object, 66 billion suns heavy, wide enough to swallow our solar system whole, blazing brighter than 1 trillion stars. And we almost mistook it for a speck of dust. The universe is hiding things out there that break every rule we thought we understood. And if you want to see where a monster like this ranks among the most dangerous things in the universe, I broke that down in another video. Go take a look. Just maybe keep the lights on.